Okay, Sapna, we are
Right.
ready.
All right. All right. It has started. Yes. So, good morning, everyone. On behalf of Department of Physics and Photonics Science, NIT Hamirpur, and Department of Physics, St. Bede's College, Shimla, I extend a warm welcome to all of you. Thank you for joining us as we celebrate a remarkable historic occasion, that is first National Space Day, to commemorate the successful launch of Chandrayaan 3. On 23rd August last year in 2023, Chandrayaan 3 successfully made his soft landing on lunar surface. So this day signifies a pivotal moment in our nation's space exploration journey, offering us a chance to reflect on our accomplishments, celebrate our progress, and anticipate the exciting future that awaits. We take immense pride in the achievements of Indian space program and extend our heartfelt gratitude to the scientists and the entire ISRO team. Their dedication and exceptional efforts have been instrumental in making this mission a remarkable success. This year, the theme of the National Space Day is Touching Lives While Touching the Moon, India's Space Saga. We are honored to have with us today Professor P.K. Ahluwalia, the esteemed National President of Indian Association of Physics Teachers, who will deliver a talk on Space Odyssey of India, a journey of self-reliance. A warm welcome to you, sir. I also extend a warm welcome to Ms. Rekha Godpade, the Secretary of IAPT. I am pleased to welcome Dr. Kuldeep Kumar Sharma, who will chair today's session. He is currently the president of IAPT Regional Council 23, that is Himachal Pradesh. I extend my heartfelt welcome to all the dignitaries, participants, and students present here. I am confident that today's talk will be enlightening and inspiring, and we all are going to enjoy it. So now I hand over the mic to Dr. Kuldeep Kumar Sharma, who will preside over today's session. I request him to introduce Professor P.K. Ahluwalia and start the session. So once again, happy National Space Day. Over to you, Dr. Kuldeep.
Thank you, ma'am. Uh, Good morning to all and happy Janmashtami. On behalf of IAPT RC23, I welcome you all in today's talk by Professor P.K. Ahluwalia, President IAPT. As a part of first National Space Day celebrations, we are all happy to be a part of this lecture series on physics education research. Professor P.K. Ahluwalia is my role model teacher, and it's always been great pleasure to listen him. Under the dynamic leadership of Professor P.K. Ahluwalia and dedicated efforts of Professor Ghorpade ma'am and whole IAPT team, we are witnessing the IAPT achieving new heights today. Professor P.K. Ahluwalia started career in teaching in 1987, 80 from St. Bede's College, and after that in 1987 he started career in Department of Physics, Himachal Pradesh University, Shimla, and after serving for many years, he retired in June 2025. And his research area is condensed matter physics, particularly dilute magnetic alloys, liquid metals, and alloys, low dimensional electron, gas, quantum dots, computational material science, and also physics education research. He has guided 16 PhD students and 34 MPhil dissertations. 2 PhD students are currently working for their thesis with him, and he has been a he has a lot of contribution in developing many centers and computational facilities in Himachal Pradesh University. He has developed a nodal center for computer application, high performing computing facility of about 128 crore for electronic structure calculations using DFT, which is a unique facility in this northern region. And he upgraded research and teaching facilities under FEAST and UGC SAP program. He has published more than 120 papers in international journals of high repute, and uh, he has been awarded Commonwealth Academic Fellowship at University of Edinburgh, UK, 1997-98, and Best Teacher and Academic Administrator Award by HP University Shimla for the year 2012. Awarded Environment Leadership Award in 2017 in individual capacity by Department of Science and Technology, Government of Himachal Pradesh. And uh, he initiated University Institute of Information Technology. He was the first director of this institute. Now today it is grown fully, and implemented campus-wide optical fiber network in HP University also. So he is director IAQ AC also, implemented student charter, designed and implemented teacher evaluation performa, and he has been uh, 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 he has been main person to implement. He has implemented RUSA at UG level in all colleges of Himachal Pradesh. He remained dean planning, and uh, his other interests are science popularization, radio feature writing, development of spoken tutorials, and community servicing, and sketching and drawing also. He is he is member of Indian Association of Physics Teacher and currently president. Member Indian Physics Association also, president Himachal Physical Society, and general secretary Vigyan Bharati Himachal. So we are proud to have Professor Ahluwalia with us today on this occasion of celebration as a part of National Day, Space Day celebration. I welcome you, and I request you to start your lecture, sir. Thank you very much
Thank you very
for
much,
being with us.
Professor Kuldeep. And first of all, I say my regards to the dignitaries present here and the participants who are very keen to celebrate the National Space Day. I'm happy that Ma'am Rekha Ghorpade is also here. She is my colleague in IAPT. In fact, she is a very important functionary of the IAPT also as General Secretary. So we work together to conduct all these things, and thanks to her that this Zoom platform is there with us in IAPT, and she takes care of it. Sapna is the co-host of this program, along with the NIT, National Institute of Technology, Hamirpur. Sapna is in St. Bede's College, Shimla. She is the head of the Department of Physics there. So with these small remarks, I think I must share the screen and initiate the lecture. So I hope you can see the screen. Am I right?
Yes, sir. Yes, sir.
Am I visible?
Yes, sir.
Yes, yes, sir.
All right. Let me just adjust few things. Okay, fine. So I'm here. And let me just start the slideshow. So welcome to this a very interesting program. Hopefully you are with me today in letter and spirit to celebrate the Space Odyssey of India. And for me, this is a great occasion to celebrate the achievements of independent India, particularly in science and technology. And it is also a great journey worth emulating in various fields of self-reliance. If you are careful in seeing what India has done in the last 75 years, I think the ISRO, that is Indian Space Research Organization, is a very bright star of Indian science and technology. And it's very inspiring also to know about it. If you are able to watch things on the screen, you must be noticing a few things. One is symbolically, you can see the Chandrayaan 3 lander on the moon surface. And this is very significant in the sense that when we really talk of space and the space technology, it is not merely a kind of an exercise in showcasing our science prowess, but it is designed to serve the people of India, and not only of India, but of the international community as well. If you will go on the internet and start searching the landmarks of this achievement, you will come across very many stamps also, which were released to mark various milestones of this journey. On the screen, I hope you can watch one very interesting stamp on the left side, which is of Aryabhatta, the first satellite which India launched actually. And on the right side, you will see a very interesting picture of Chandrayaan 2. Also, you will watch at the bottom of the screen picture of rupees 2000 note. And on it, you can very easily see the MOM, which was launched to reach Mars. I hope you know the full meaning of MOM. It is one of the longest journeys which any satellite has undertaken, initiated by India. My talk actually is having the following outline. Importance of this National Space Day. Then we will try to look at why ISRO is such a wonderful place and what kind of approach it has to achieve success after success. And I'll just point out one approach which it follows called Golden Circle approach of ISRO. Then we will go through the genesis of India's space program. What are its focus goals and their steps or echelons? What are ISRO's achievements? Today, when we are talking of ISRO, what is the importance of ISRO in the space economy? And also we will look at how ISRO achieves a continuum of success stories in the end. Now, there are some iconic figures which you can see on this slide. And this is the journey which we are celebrating today as National Space Day. This is the first National Space Day to mark the landing of Vikram lander on the lunar south polar region. And this is, I think, a big leap which India has undertaken. I don't think anybody sitting in this audience has not watched this landing on the television live. So we have traversed from a place where we were carrying our rockets on bicycles, and they were being, fabricated in very, very challenging circumstances. The picture in the middle is that of an iconic figure of the space program of India, Dr. APJ Kalam, and another scientist, Arvar Mundan, who is sitting with him, is in his vest. And that shows that they must have worked to achieve this kind of a success starting from zero. And that is where we are today because of such efforts. Now, when India initiated space program, people started saying India is undertaking such a costly affair. Is it desirable or not? And the answer to this was given by the initiator of the space program here in our country. And that was Professor Vikram Sarabhai. And he stated that in a very nice fashion. There are some who question the relevance of space activities in a developing nation. And for us, this is a commitment, and this has got a purpose. And we can see today that with what commitment and purpose this program was initiated, and it has led us to so many benefits around us that not even a single person is untouched by its achievements. If I am able to talk to you, thanks to the satellites, which are communication satellites through which this broadcast must be reaching you from somewhere. So this is the beauty of this whole exercise, which we are really seeing unfolding today in this particular story. Now let us try to look at what are the dimensions of this post program when we started it. In the name of ISRO, you see one word very important in that. Indian is there, space is there, organization is there, but the most crucial term in that is research. So that means we were ready to undertake research to get the technology and bring innovation in achieving our goals. Second thing which was there was, this is not a program that you do it today and then you shut it down, and then after 6 months you again start it and so on. It is a 24/7 program. There are so many satellites which are around us working round the clock, being controlled from the mission control centers for various missions. The third dimension of this program is the importance of reaching everybody. It is not that we are doing it for scientists. It is not that we are doing it only for, say, industry. It is not for just scientific research. It's much more than that. So right from the day one, the authors or initiators of this program were very clear about one fact, that this is a program which must reach everybody. And for that to happen, there was one very important essential component called scalability. That we do a small pilot somewhere, but then that pilot is not just a small event for us. It is a way to check how this program can be spread all across the length and breadth of the country and beyond. This is also very crucial to appreciate and understand. So scalability is a very important part of it. Now, you can see some very interesting pictures on the screen. They are historical pictures in the space program. There are three personalities which are there on the screen. One is Professor Homi Bhabha, other is Professor Vikram Sarabhai, and third is our first Prime Minister, Pandit Jawaharlal Nehru. I think these are the three people who, before independence, had started interacting about the status of science and technology in India after independence. Fortunately, Pandit Jawaharlal Nehru was a science student and he had done his typos in science. And Vikram Sarabhai and Homi Bhabha were very well known to him. Particularly, Homi Bhabha was known to him from his England days itself. So when in the Second World War, Professor Bhabha came back to India and could not go back to UK, he settled himself in Indian Institute of Science, Bangalore, where Professor C.V. Raman was the director. And there, Dr. Vikram Sarabhai joined Sir C.V. Raman as his research student. So now you can imagine the bonding which these two people must be having with each of them. And Pandit Jawaharlal Nehru was knowing them from the day one. So when they started thinking about unfolding the science and technology in the country, they were having a very, very close access to the political leadership of the country. Had this not been there, I think the rate at which we could work would not have been possible. So what was their approach right from the day one? Their approach was this golden circle approach, where we go from why to what. And what is this why? Why means whenever we are going to do anything, we will ask this question, why? What is the ultimate thing which we would like to do as a result of the effort which we are going to make? Once that clarity is there that why we are doing it, for example, if we look at it today, it was to reaching out to more than 1.4 billion people in the country. At that time, the population was just 40 crores. But that mission was started with this program in mind, that why we are doing it, for whom we are doing it. Once you are clear about why, then the next thing which comes is how we are going to do it. And after that comes, if we are going to do it in this way, what will come out of it? These are three, I think, steps which are from day one very clear before Indian Space Research Organization. Now see, when we talk about where there is a will, there is a way, the first thing which this trio started thinking about was to make rockets. And for that, we required a place from where we could really launch these rockets. And they found a place in south of India called Thumba. And they found that it is on the magnetic equator. And this is a very nice place from where we can initiate our launches and start doing something. Now, remember, rocket is a very important part of everything else. And if I may recollect, whenever I celebrate Diwali, one of my favorite, pyro device which I buy is the rocket only. And I think nobody sitting in this audience must have been ignorant about that. And that place where they wanted to have it, there was this old church. So they approached the father of the church, the pastor of the church, that we want to have our India's first launching center here. Can you please help us? So he was, having one question only, that what kind of help do you want from me? They said that we want that you please give this church to us for establishing our launch center. And look at the greatness of the Christian community and the father, that they passed a resolution that this church be given to ISRO for creating a launching facility at this particular place. Now, this is how we begin from a very holy place, this program of space research in the country. Now, when the first launch was made from this place, students were also invited there. Even now you see in Sriharikota, whenever there is a launch at a distance about 8 or 9 kilometers, there is a gallery where people can sit down and watch it. Here you can see on the right side a picture of students in NCC dress looking at the sky, seeing the rocket being launched. Very, very exciting moment for them also. And it must have etched a lifelong memory on their minds. And at the bottom, if you try to see, we can see Vikram Sarabhai speaking to an audience in which we have the Prime Minister of India sitting, Mrs. Indira Gandhi, and also the Chief Minister of Kerala at that time, Nimundripad. So this is the historical beginning of the launching of the things. Now, to give it a formal shape, in 1962, Vikram Sarabhai formed an Indian National Committee for Space Research under the Department of Atomic Energy. Actually, Vikram Sarabhai and Bhava both were part of the Atomic Energy Agency of India. And under that program, the launch of India's first sounding rocket, Nike Apache, was made in 1963, which marked the beginning of this journey. And this picture on the top is of that sounding rocket being launched. When we are talking about sounding rocket, basically they are low Earth, rocket launches within the atmosphere, but are very important for gathering experience in gathering information about atmosphere around that region in which we are launching this particular rocket. It was in 1969, after the death of Homi Bhabha in 1966, that Vikram Sarabhai, who had then become the chairman of Atomic Energy Commission and director of Bhabha Atomic Research Center, the ISRO was formally launched in 1969. And this was a very important second landmark in formalizing the space program of the country. Now, what were the focused goals for us at that point of time? Now, see, we want to send satellites. We want a transport system for that. And that actually means that we needed rockets or launch vehicles. Second thing which is there is we wanted to have terrestrial infrastructure, means launching pads, tracking stations, etc., spread over the length and breadth of the country. Third thing, which is very, very crucial, is what are we going to take with this rocket? That means, what are the payloads? What are the satellites which we want to take there? And also, this payload was designed as per the needs of the users for whom we are carrying this. So you can see in this picture very clearly a few very important things which ISRO does. On the right top, you can see that this is the Sriharikota launching station. Then we also have below this the kind of data which we collect when we try to get information via the satellites which we launch through the payloads which we have put on top of this satellite. And also, you can see now a kind of a constellation of satellites around the Earth, which we have launched for reaching out to the people across the country. Now, this is how we have been really working. These images I have taken from ISRO's website. Now, actually, once we had decided that these are the broad goals, we started looking at each and everything systematically. For example, first of all, we started focusing on space transportation. For that, we required launch vehicles. And today, you know that we have polar satellite launch vehicle, geostationary satellite launch vehicle, reusable launch vehicle. We have also, we are readying for human space flight. Then parallelly with it, we went for space infrastructure, which is Earth observation, communication, navigation, planetary exploration, and so on. Then we had space applications because we were, if we were in fact having space transportation or space infrastructure, we were readying ourselves for these space applications. So we started, doing national level projects for these kinds of things. And environment monitoring, land, ocean, atmosphere, and for strategic purposes like for defense forces also. Then we thought of building capacity, human resource building, indigenization of the program, technical infrastructure, international cooperation, involvement of industry and academia. If you will go through the journey of India's space program, you will find that these are the steps which we have actually traversed to reach the place where we are today. I hope you must have seen a latest video which was viral across various, social media sites. And that was of what happened in Kerala. We were, able to track from the satellites, minute by minute, disaster which was happening in that particular region in Wayanad. And we were giving warnings that this is likely to happen. And we should be careful about providing mitigation to people regarding this. So, one of the very important things is disaster risk reduction, which is obvious in this example. Next is national resource management. Now, when a satellite is there in the space around us, it can have a bird's eye view of everything around where it is targeted. And that means that you can see so many things which you may not see otherwise. You can have an eye on the ocean, you can have eye on the land, you can have an eye on your, say, water resources, you can have an eye on your crops. You talk about anything and you find that it is there. So what we have done is through these very well-defined goals, which were very clear right from the day one in our mind, we were able to proceed further. So let's have a look at what ISRO has been able to do. ISRO has now 87 plus launch vehicles. And these are of 5 types. One is satellite launch vehicle, simple satellite launch vehicle. Aryabhatta was actually sent in outer space on a Russian rocket through their launch center. But if we were to be self-reliant, we must think of our own launch vehicles. And one of the first such launch vehicles which was built was through SLV. And the story of launching of SLV is also very, very challenging. When the first launch of this was conducted, it was a disaster. And APJ Kalam was actually a leader of that particular project. But the way ISRO works, what happens is when something is successful, the team takes the credit. But if something is a failure, the chairman of the ISRO takes the responsibility of that. And at that time, the chief was Professor Satish Dhawan. And the moment this failed, he actually went in the press conference and said that this is what has happened, but we are sure that we will overcome this problem. And second time when the SLV was a successful launch, it was APJ Kalam who was addressing the press conference and Satish Dhawan was in the background. So that is how, the culture of working in ISRO actually developed. The second satellite launch vehicle was augmented satellite launch vehicle. Then we have polar satellite launch vehicles, and 5 variants of these are there. PSLV C, D, XL, CA, and DL. Then we have geosynchronous satellite launch vehicle. It also has 3 variants, GSLV Mark 1, GSLV Mark 2, and GSLV Mark 3. It is GSLV Mark 3 through which we launched our Chandrayaan satellites. And then today, we are talking of having small satellite launch vehicles. And only recently, there was a launching of this small satellite launch vehicle also. And it is very significant that sometimes people would come, say, to the ISRO and tell them, look, we want to launch a particular satellite, but we want to have our own satellite launch vehicle. Can you provide us some prototype for that? And ISRO is ready with that also. And what happens is, why we went for so many generations of these launch vehicles? Because what we want to do with every improvement is increasing the size of the payload. That what is which we can carry and put in orbit around Earth itself. So we are ready today about all these ideas. So we started with sounding rockets, and they were actually 2-stage solid propellant rockets used for probing the upper atmospheric region and for space research. And to begin with, Russia, at that time it was USSR, Soviet Republic, United States of Soviet Republic. They were very, very, helpful for us to have these, launch vehicles. And the rocket was able to go up to a height of between 85 kilometers and 150 kilometers, and the payload was of just 70 kg. Then we had satellite launch vehicles. And the SLV-3 was launched on July 18, 1980 from Sriharikota range, which is now very famous. And that infrastructure at Sriharikota is the base structure for more major launches which we have done from there, ASLV, PSLV, GSLV, and light vehicle launches also. Then we have augmented launch vehicles also. These are low-cost intermediate vehicles demonstrating the technical worth of ISRO in its strap-on technology and more. Now, in this picture on the right side, you can see that there is a main part of the rocket, and there are 2 other rockets which are strapped on it. So when we want to launch it, we make use of this kind of a additional rocket which is provided with the main rocket to launch the vehicles. And that is why We are calling it as augmented satellites. Now, the most important thing which happened in polar satellite launch vehicles was to equip them with liquid stages. And PSLV has been the workhorse of ISRO, and it can launch satellites into different types of orbits like sun synchronous polar orbit, low Earth orbit, geosynchronous transfer orbit, and even deep space mission. And PSLV has completed till date about 48 missions and placed satellites in different orbits, which include India's remote sensing and communication satellites, maiden lunar mission Chandrayaan-1, Mars orbiter mission MOM, this maiden sun mission Aditya L1. Then we have X-ray photography satellite ExpoSat, Indian Regional Navigation Satellite Constellation, which is equivalent to what we call as GPS service of our own. And there are many foreign satellites which we have launched with the help of PSLV. It is through this PSLV only that on 15 February 2017, we were able to launch in one go 104 satellites in a sun synchronous orbit. And there were many, technology success demonstrations which happened as a result of this. Then we have this geosynchronous satellite launch vehicle. You know that geosynchronous satellite looks as if it is stationary at one place on top of Earth because its time period synchronizes with the time period of the Earth around its own axis. And this GSLV, again, is a three-stage vehicle with liquid strap-ons, a solid rocket motor, and also a crypo upper stage. Again, when we started working on this, Russia was there to help us, and they provided those cryo stages, and later with cryogenic stage developed by ISRO became the most important part of this launch vehicle. And almost all INSAT satellites series has been launched with the help of this GSLV. Then we have LVM-3. It is a three-stage heavy lift launch vehicle, and it's a completely indigenous development of ISRO. And it has two solid strap-ons, a core liquid booster, and a cryogenic upper stage. And it can carry 4-ton class of satellites in a geosynchronous transfer orbit, or about 10 tons to low Earth orbit. Remind it, we are talking in terms of tons now, not in kilograms. So that is the capability which we have today available with us. And the latest, the one GSAT is now part of the commercial missions. It is also part of the Chandrayaan 2 and 3 missions. Then we also have small satellite launch vehicles. It is a new launch vehicle of ISRO, capable of launching mini, micro, or nano satellites. So mini means 10 kg, nano means a kind of a 500 kg mass. And they can go or take these satellites into a 500 kilometer planar orbit. And it is a three-stage vehicle with all solid propulsion stages. And it has already completed 2 successful launches for Earth orbit, program. Then lately, we have been working on human-rated launch vehicle, HRLV, which we call as. It is a version of LVM-3, which is expected to take 2 to 3 crew to a height of 300 to 400 kilometer orbit. And I think we are already working in that direction. On the right side, you can see that we have a very interesting picture. There is a rocket, but on top of that rocket, there is a kind of a figure which resembles a kind of an aeroplane that is like, it is being carried by this, but it is a reusable launch vehicle, means that you take it to the orbit outside, and then you can bring it back also. We have already tested it, and it has been a success story. And I think in this picture, you can see this RLV, reusable launch vehicle landing experiment. It was called LEX. It has already been completed, and this was a very interesting exercise, which was done for very many reasons in mind. It could land with a velocity which exceeded 320 kilometers per hour compared to about 250 kilometers per hour for a commercial aircraft, and 280 kilometers per hour for a typical fighter aircraft. After touchdown, the vehicle velocity is reduced to 100 kilometers per hour, and then we apply those brake parachutes to bring it to a halt. Now, this is a very interesting list of the various satellites which India has launched. So we talked about launch vehicles. Now I'm coming to the satellites. We have communication satellites starting with Aryabhat. And it is with the help of these communication satellites that we have been able to launch very many programs. But once again, let me tell you that India, right from the day one, had started thinking of these communication satellites as a vehicle for reaching out to people. At that time, when we didn't have a satellite, India had a kind of a collaboration with NASA, via which they started a program in which the television programs were beamed at different panchayats in the country. That was in early 80s. That was the time when we were looking at all these things, that how to really get into that kind of a mode where we start reaching out to our people. Now, after that, you can very easily see here we had INSAT 1A, 1983, and this was basically the beginning of the color television era in the country. And Asiad, which was conducted at that point of time, was beamed through this satellite communication system itself. Then we had GSAT, and now we have reached GSAT 30, which is a very, very important landmark. Then we also have Earth observation satellites, and Bhaskara 1 and 2 come in this series. And then we have a series of Indian remote sensing satellites also. We have, after that, some satellites for specific purposes. Resource sat, for example, Cartosat for mapping purposes, OceanSat, ResourceSat 2, ReSat, Saral, Cartosat 2. So these are, improvements. And then we thought of having our own constellation of navigation satellites. Now, they are equivalent to what I told you, the service which Google provides to us via GPS. You know this, you use it on daily basis. But today we have in our own country this service which we are calling as NAVIC, NAVIC. Apart from this, we also have what we call as scientific research satellites. Now, when I am saying scientific research satellites, basically these are the satellites which were made for the scientific community. For example, some people want to look around the, say, deep sky, or we want to look at certain things which involve some scientific payload, maybe for mapping, imaging, X-ray photography, etc., etc. So these come under the category of scientific research satellites. Aryabhatta was one of the first satellites. It was the one which was built in-house. Bhaskara 1, Bhaskara 2, Chandrayaan 1 also was a scientific research satellite. Mangalyaan was also a scientific research satellite. And you know that it took 9 months for it to reach the Mars. And it was a success in the first attempt itself, the first of its kind in the whole world. Then we have AstroSat, particularly to help the astronomy and astrophysics community in the country. And the latest one, the Aditya L1. Now, one thing I would like to really tell you that today we have reached a stage where we are not limiting it to specialized satellites. We are even, encouraging student community and academia to build their own satellites and send them in the outer space and do experiments. For example, in 2010, there was a satellite which was launched, StudSat it was called. Then SRM, I hope you know this institute in the south, particularly in Chennai. They launched in 2011 SRM SAT. IIT launched its own Jugnu, and so on. So it's a great success story. And if you now look at these pictures, you will find that this success story is helping us in thousands of ways. Weather forecasting, television broadcasting, radio networking, telecommunication. Can you imagine the mobile communication without satellite communication? Answer is no. Then we have tele-education. I mean, thanks to this kind of facility which was there in our country, that when COVID came, we were able to switch over to the mode by which the teachers could access the students, reach out to the students, and students could talk out to the people. Now, your ATM works with the help of these satellites. DTH is an example where you are receiving direct communication signals from the satellites. And the best part of it is this, that it is distributed, the signal is getting distributed equitably. It is not this that in my home, DTH gives me better signal than my next neighbor, the signal actually gets weakened. It's not at all. Weather forecasting, cyclone warning service. Cyclone warning service is one service which has saved thousands of lives on our coastal regions because of timely cyclone warnings. In Odisha, in Tamil Nadu, in Kerala, and almost in all, these states which are on the shores of the country, we have been able to make use of it in the best possible manner. Today, I have a weather forecast which is correct for the different hours of the day. I know today that I will have rain at 5:30 p.m. in Shimla. Telemedicine. Can you imagine that we are able to reach out with expert doctors from a remote area and seek his or her help? So that is the beauty of these things. Now, I think we must not forget when we talked about all these satellites, the story of Aryabhatta itself. It actually began under the chairmanship of Professor M.G.K. Menon and Professor U.R. Rao. Professor M.G.K. Menon was the director of, a chairperson of ISRO at that time. And Professor U.R. Rao was the leader of the satellite center. He was the director of that. And they were given a task to design a satellite. And they took up this task. Now, what was the spirit in undertaking these kind of tasks? You can see on the left side, there's a beautiful quotation of U.R. Rao, where he said, if anyone can do it, we can also do it. If no one can do it, then we must do it. It was with these kinds of, what you call motivations that we see the rise of the achievements of the ISRO. Professor M.G.K. Menon, let me tell you, was again a physics professor. He was also director of TIFR at that particular time. Our first chairperson of ISRO, Professor Vikram Sarabhai, was also having a background of physics. Similarly, you will find that there are many leaders who came from physics background into this technology. And let me tell you one thing more. They had no formal training of any kind of science and technology of this area. They made sure that they learn it, do with their own hands, and start, having technology, acquiring technology on the go. And you can see that Professor U.R. Rao later wrote 3 books on what he had done. One was Perspectives in Communications. It is in 1987. He had started thinking about it then. Space and Agenda 21, Caring for Planet Earth, Space Technology for Sustainable Development. Now, these titles, if you look at of these books, you will find have the same motto, which is that of the National Space Day today, that we want to reach out to the people for whom it is actually meant. There is a very interesting story of the naming of Aryabhatta also. At that time, Indira Gandhi was the prime minister. So it was to be given a name. So they thought, why not suggest 3 names and send it to Mrs. Indira Gandhi? So one name was Aryabhatta. Second was Jawahar. That was the name of the first prime minister of India. When it came to making a choice, Indira chose Aryabhatta as the name, which signified the achievement of India in mathematics and science in its earlier eras. Another very interesting feature which underlines that how ISRO could achieve this kind of a mission is suggested by Satish Dhawan. And from the day one, you will find that India has achieved all these things in mission mode. And it is very important that we identify the missions. So this says if you do not have a mission, no problem will occur. But if you do have a mission or task, definitely problems of varying magnitudes will crop up. But problems should not become the master of the individuals. Individuals should become the master of the problem, defeat it and succeed. And this is the spirit with which, when it came to giving the credit, Professor Satish Dhawan gave credit to the team. And when it came to taking the blame, he took it upon himself. Now, you must be wondering that how a typical mission program is initiated in ISRO. I was very happy to read one very interesting paper by Professor K. Kasturi Rangan. He is the same man who is behind the NEP 2020, National Education Policy 2020. And in that paper, he had given how a decision for making Chandrayaan-1 mission was undertaken. I hope you remember that it was in 2003 that Prime Minister Atal Bihari Vajpayee announced from the ramparts of Red Fort that we will have a Chandrayaan-1. And, you can see the timeline also. Presentation regarding this was made on 1999, May. In October, it was made to Indian Academy of Sciences. Then it was made to Astronomical Society of India in 2000. Then it was made before National this feasibility assessment. Then it was brought before Parliamentary Standing Committee. We have a very democratic system. Political sensitization is very important for that. Then defining the mission through a national task force. Review is a very important mechanism in ISRO. Whenever they do this, they go through the exercise of review also. Why when something is successful, why something is not successful. Reviews are very important. Then endorsement by space mission, and then announcement. We started in 1999 we took various steps in 4 years to reach a stage where we could announce it. So there is a well-defined, algorithmic thing which is at the back of it. We always believe in need assessment. We also try to look at what are the goals for national development. How are we going to plan it? How are we going to organize it? Are there any policy or strategy things which we need to take care of? And then what are the long-term strategies which are there with it? All these are very crucial features which go into the making of a mission. Now, it was under the chairmanship of G. Madhavan Nair that Chandrayaan-1 lunar probe was actually launched. And during his tenureship, try to see how ISRO started running. 25 successful missions were accomplished by ISRO. Development of multi-stage launch vehicles, which I described earlier, happened. And this culminated in the launching of the Chandrayaan-1, which went very near to the moon and started gathering picture. There were not only our own national payloads on it, but there were many international payloads also on that, which were actually the kind of what you call scientific experiments, which other countries also wanted through this launch of Chandrayaan-1 itself. And at that time, he also talked about that a time is going to come when space travel is likely to be a kind of an affair, the way we travel through airlines. And at that point, he also mentioned that when the time will come, we should not be in a position that we have to borrow things from other countries. We should have our own such launch vehicles in which we can send people out, maybe just for tourism purpose itself. So now if you once again try to look at what we have been able to do, forestry, environment, agriculture, water resources, ocean applications, land use, land cover, all these can be taken care of by ISRO satellites. And the need is provided by whom? The need is provided by different departments of the government, or maybe the private agencies who want to use it. If Airtel signal is coming to you, the private agency Airtel has borrowed a transponder on a communication satellite to reach you out. So now you can see that maybe water resources, a mission of the Ministry of Water Management. Agriculture resources, maybe a mission of the Ministry of Agriculture. Land use and land cover, maybe a mission of, say, urban and rural development. Ocean applications, maybe a mission of science and technology itself. One of the first applications which ISRO actually developed was for fishermen. Actually, there was a lot of gratitude which ISRO wanted to show to the people in Thumba who had given them their land for creating that launching facility. So they wanted to help the fishermen there. And they said via a satellite, we can always tell these fishermen where is the school of fish actually in abundance. So they can be pinpointed to go that place and get the best harvest of the fish from there. So this is the kind of, minute, what you call planning, which went into this. Now, this is something which we should be very, very proud of. We are having a constellation of satellites, which is basically numbering 9. And it is the given name as Navik. And with the help of this, we are able to now provide navigation services. If you see the picture on the right-hand side, you will find that these satellites are in communication with, say, this ocean liner to a bus, maybe in some remote areas to trucks, etc., for navigation purpose. So you can reach out anywhere. And there is an importance of this program actually otherwise also from strategic point of view. Suppose I'm using Google for navigation. Suppose somebody says that, look, we want that in this particular area, we would not let people use this navigation facility. Or maybe if they use it, it may take us to a place where we never decided to go. We were deciding to go to, say, a temple, and it landed us into a jungle. No, we don't want that. Strategically, we should have our own navigation system. From defense point of view also, it's a very, very important. So please do remember that these kinds of missions under Gagan, etc., are very, very crucial. Precise timings. We have recovery technologies. We have to have orbit controls. We have to have atmospheric studies. We need all these facilities in-house, not borrowed from somebody. When we were trying to learn things, I think it was okay. But once we had done it, then we should be on our own. And that has been one of the efforts right from the very beginning. So this is another picture of the Chandrayaan and the related things. These are some of the satellites which were sent by university or academic institutes. And we are very much part of that, in the sense that academic community is given a chance that they can bring a satellite of just 5 kilograms, and it can be launched for them by the ISRO itself. So an academic institution may not have the wherewithals of launching these things, but they can do it very easily with the help of the facilities which are being provided. So we have already achieved certain missions. But there is one very important property of these missions, that they are very low cost missions compared to what the USA has been spending on sending a satellite to Mars. Our mission cost is very, very small. For example, in the case of this Mars orbiter mission, Mangalyaan, the cost was just 450 crores. It was an astonishing figure for NASA people, that how could India manage all these things at such a low cost? Now, as a result of this, that the kind of now technology which we have got, we are now planning some new missions also. Well, one is this Gaganyaan, in which we want to send a crew to the outside space. Then lunar polar exploration mission. Then we have Venus orbiter mission, Shukrayaan we are calling it as. And already we are thinking of having Mars orbiter mission 2 after the successful launch of this. In fact, there are many inspiring stories which have emerged from ISRO. I had an opportunity to meet Professor K. Radhakrishnan here in Shimla when we honored him with a doctorate degree by Himachal Pradesh University. He was very categorical about the success of Mangalyaan mission. It was then that he had come after the successful launch of MOM itself. When the opportunity came his way, he writes in his memoirs, I didn't want to let this opportunity pass. And I took the responsibility to prepare myself. I did it in earnest. It was a penance of 6 months. I would regularly wake up at 4 a.m. to brush up my knowledge of launch vehicle technologies and systems and prepare myself. I firmly believed that even if I didn't make it, my learning would never go to waste. I think this is a very important message which is coming from this. Whenever you learn anything, sometimes you may feel that you are wasting time. But believe me, I fully agree with Professor K. Radhakrishnan that learning never goes waste. And there are number of missions in his 5-year tenure which he actually carried forward. these were 37 space missions which he actually guided. In that, re-entry experiment of an uncrewed cubital was there. Indian cryogenic engine on GSLV was there. ISRO's joint satellite missions with French National Space Agency was also there. By the way, let me tell you that till the launch of INSAT series of satellites, we didn't have that kind of a workhorse like GSLV Mark III, which could send geosynchronous satellites out in space. So we used to carry them to the French National Space Agency, use their rockets to launch these missions. And now what we are finding is there's the same agency is saying, okay, why don't you launch our satellites also through your satellite launch? Then we have one very important set of things which happened after Professor Radhakrishnan. The chairman was Professor Kiran Kumar. Again, he is a physicist actually. And he is a man who is a man of image processing actually. And he really worked on very many such collaborations in which the image processing systems were actually used. Lately, in connection with the National Junior Science Program, I had an opportunity to meet him and listen to him while he was addressing young students. It is, in fact, a great achievement that he was also given a France highest national award for his contribution to Indian-France space cooperation. So he is a man who is highly technical plus a collaboration man of ISRO. He proved to be a collaboration man of ISRO. And it is under him that we started launching our journey towards small satellites. As I was telling you, AstroSat mission and ExpoSat missions, these are two missions which are scientific missions of the ISRO. I've already talked about it. Now, Chandrayaan 3 is an icing on the cake, but it followed a failure. And I think nobody can forget this picture which was beamed on the television when the chairman of ISRO at that point, Dr. K. Sivan, had tears in eyes, and our Prime Minister Modi consoled him. And after that, what we saw, we learned something, why it didn't work. We improved upon that, and the success of Chandrayaan 3 is before us under the leadership of Dr. S.P. Somnath, who is current chairman of the ISRO. And there are many science payloads on Chandrayaan 3, and we already know, in fact, on August 23, the science papers and the science mission results were also made public during that particular period. One of the success stories of Chandrayaan missions is finding of water on the moon itself. So this is again a very important part. And then Aditya L1 mission, study of sun at the closest point, and a point where our satellite will just go and sit without pulls and pushes of the gravitational pull of either sun or other satellites of the Earth, like other planets, etc., which are there. Please do remember, these are very complex, exercises which one needs to conduct. Lots of simulations go into this. Lots of, what you call artificial intelligence or machine learning also goes into it, because a stage comes when we would like these projects to be on auto mode. And during that period, if it has to take some decisions, how it is going to take decisions. So we have also now mastered those kinds of technologies of artificial intelligence, or more technically speaking, machine learning technologies, which help us to achieve all that. And in Chandrayaan's Vikram lander, and the pragyan which came out of it, we know that it was most of the time is in autonomous mode. It was able to see where to move. Is there an obstacle? Is there a ditch where it may get trapped? How to manage that? All these things were in an autonomous mode itself. So one of the very important names which I mentioned in the beginning and which we cannot miss is very important to talk about. And this is a kind of a strategic offshoot of the Indian space program. When it came to providing missile shield to the country, one of the most experienced persons with ISRO, Dr. APJ Kalam, was spared and he was given to DRDO to start the missile program of the India. We today talk about Prithvi, Agni, Nag, all these kinds of missiles. Thanks to Professor Kalam that we could do this. In his book, Wings of Fire, Professor Kalam writes about how he started this mission. He came to DRDO, talked to the scientists of the DRDO for about 2.5 months, and then he decided to choose the mission leaders for each of the missiles, Prithvi, Nag, Agni, etc., etc. And then he called all scientists into the auditorium of DRDO, and he said that today I'm going to declare the mission leaders of these particular missiles itself. And he picked up 5 people, and they were all young. And as is true in the case of science people, at the end of it, they will always ask, have you got any question? So he posed this question, and a hand was raised at the back of the auditorium by a very senior scientist, an old horse of DRDO. He said, APJ Kalam, sir, we don't understand how you have picked up these 5 Pandavas for these missions. You know what was his typical reply? That you will find in Wings of Fire autobiography. He said that these are the 5 Pandavas who are married to a Draupadi called dedication, devotion, and he listed all their qualities before them. And after that, there was a silence. Nobody raised any further question. And he always, believed in one thing, and that was a continuous excitement in doing the things, thinking, visualizing, and above all, believing. That is something very important. It has been the hallmark of the personality of Professor APJ Kalam. And I think that is why India, gave him Bharat Ratna much before he became the president of the country. On 15th of August this year, particularly Prime Minister Modi talked about ISRO and space economy. And if you had heard his Man Ki Baat on Sunday, you will find that he brought the startup, members of a particular startup to tell countrymen that what they are doing. And in his speech, he has made a very, very important point. And there he wanted to attract young people. So he said, मेरे साथियों, मेरे नौजवान इस तरफ ध्यान दें. स्पेस सेक्टर एक फ्यूचर है. हमारे साथ जुड़ा हुआ एक महत्वपूर्ण पहलू है जिसे हम बल दे रहे हैं. हमने स्पेस सेक्टर में बहुत रिफॉर्म किए हैं. जिन बंधनों में हमने स्पेस सेक्टर को बांध के रखा था, उसे हमने खोल दिया है. आज सैकड़ों स्टार्टअप स्पेस के सेक्टर में आ रहे हैं. वाइब्रेंट बनता जाता हमारा स्पेस सेक्टर भारत को एक शक्तिशाली राष्ट्र बनाने का एक महत्वपूर्ण अंग है. और हम इसको दूर की सोच के साथ मजबूती दे रहे हैं. आज प्राइवेट सैटेलाइट, प्राइवेट रॉकेट लॉन्च हो रहे हैं. यह गर्व की बात है. आज मैं कह सकता हूं, जब नीति सही होती है, नियत सही होती है और पूर्ण समर्पण से राष्ट्र का कल्याण यही मंत्र होता है, तो निश्चित परिणाम हम प्राप्त करते रहते हैं. I think these are very interesting words which Prime Minister spoke on 15th of August 2024. And I think here is a call for the young minds who are sitting in this audience also. Now, when we are thinking of this ISRO and space economy, we are very clear that these space startups will play a crucial role in complementing and enhancing the capabilities of ISRO's space program in several key areas. One is innovation and technology development. Space startups bring fresh perspective, driving technological advancements in satellite design, propulsion systems, communication technologies, and they contribute towards developing cutting-edge solutions that augment ISRO's missions and opportunities. Then resource pool for specialized services, data analytics, small satellite manufacturing, satellite communication solutions, diversified expertise provides ISRO with additional resources. This is very important. Collaborative partnerships. This collaboration of ISRO with startups in various projects is leveraging fast progress of the missions, agility, flexibility, some very important unique capabilities to accelerate the development and so on. So such partnerships are really going ahead. Market expansion. So now we are offering various countries, come on, we can really provide you this kind of a service. So a vibrant space ecosystem is getting raised up through what we call entrepreneurship and investment in raising the capability, economic growth and job creation. This is also one of the various programs of this kind of a hand-holding of the startups by ISRO. And this is very, very important that this may lead to even job creation. Capacity building and knowledge, technical guidance, mentorship, and opportunities for a collaboration to space startups. And this is also nurturing a pool of talent, fostering expertise, and building a robust ecosystem of space and space economy itself. And today we are talking of promotion of space entrepreneurship. There is a program which is called Indian National Space Promotion and Authorization Center in space. It aims to streamline policies and regulations to encourage private sector participation, including space startups in the Indian space program. Here are some of the startups which are already working. You can see a satellite which was made by this startup Agnikul. This is basically a very small satellite head, and main part of it is the rocket. This rocket has been fabricated by what we call 3D printing, something which is very interesting, and we must not underestimate these things. So there are various startups. Pixel, Agnikul. Pixel is giving us Earth imaging satellites. Agnikul, launch services for small satellites. Skyroot, indigenous launch vehicles for small satellites. Beltex, propulsion systems and in-space transportation. Astrom Technologies, high-speed data communication solutions. Kava Space, satellite-based data analytics solutions. So there are so many things which emerge from our activities around our space missions. But then the question comes, how ISRO achieves a continuum of success stories. And I talked to Professor K. Radhakrishnan, and he shared with me 7 mantras of ISRO in a small write-up, which he titled, Why I Adore ISRO. One vision, one team. The guiding vision of ISRO had been and is still shared at all levels over the generation. The organization evolves continuously and enriches its vision and is a natural process. The lunar and planetary explorations are apt examples of this. Then national priority over everything else. So national priority means what are our needs for national development, actual needs of the user community. And that brings, a kind of a far-sightedness to the programs of ISRO itself. Then we have long-term planning. It is not that you do it and after that you forget it. there is a great obsession for self-reliance. And not only that, timelines to be met and services made available in a time-bound manner. So for this, long-term planning is very, very crucial. A sublime blend of youth and maturity. So they want to make use of inventive power of the youth and also bring in the wisdom of the elders. And this has given a great potential to ISRO itself. So you will find there is a kind of a culture in review meetings. A young scientist or a technologist can get up and talk about some point which the people respect. It is not that he is young, he is not supposed to speak out. The culture is that you must come out with your ideas, views, etc., so that we can improve. And this is the kind of culture which has actually written the success story of the ISRO itself. Constructive conflicts. Many a times you will find that we cannot always agree on everything. So we have constructive criticism, which can be from internal sources and from external sources. And they are taken in a positive way, taken on board. And only then, once these are sorted out, actionable decision is worked out. But once the decision is there, teams traverse the chosen path which has been decided with conviction, great determination, and devotion without raising any doubt. Nerves and verbs. This is very interesting. ISRO recognizes that the difference between the success and failure in space missions is very thin. Chandrayaan 2, with that at the end glitch, sometimes you may feel that, oh, it failed. No, it didn't fail. It gave us many lessons. So to take care of all these things, there is a high level of preparedness for any possible contingencies and emergencies, coupled with harmonized effort of several hundred members of the mission team to diligently execute the sequence of operations with attention to minute details. So this is very important. Then failures are part of the learning. This is very crucial. And I think we must learn from it. ISRO exhibits resilience to reflect and revive, continually taking lessons from its failures as well as successes. Most important, that leader takes responsibility for the failure without pointing fingers on others. And when success comes, the credit is passed on to the team. This is, again, a great way of going ahead. So I hope you have gone through this wonderful journey of ISRO today with me and enjoyed it. These are some of the references which I have used for creating or making this presentation. If there are any questions, you are most welcome to ask me. I am coming back to you. So I'm stopping sharing. So I can see that there are some things in chat. There was a
comment. There is a comment from Dr. Kuldeep.
Very enlightening talk, sir. Please suggest how our BTech and MSc students can get into the space technology program from their career point of view. Dr. Kuldeep, there is an internship program which actually ISRO conducts, where they invite students from technological institutes and university departments to come and work on some small project with ISRO teams. I think that is where the opportunity window lies. If we are able to tap that, I think we can start thinking of maybe we will hear NIT Hamirpur is going to make a student satellite for launching in future itself. So, and they are very, what you call open. They can come to you, they can talk about these things. They have a program of capacity building also. So if you have some kind of a project in your mind, you can really take the help of that. You can have some kind of a science experiment which you would like to put payload on any of the satellites built by the students. yesterday, if you have watched the Prime Minister's Man Ki Baat, he actually spoke to a group of 5 IIT students who have started the startup. And very beautifully, it was explained that what they are doing, in what way they are actually doing it. And one of the very important messages from that group of students which came was this. Today, the students have stopped thinking of going abroad because they are finding these kinds of opportunities are available to us within the country. So I think this is where the crux of the matter actually lies. So if there are any further questions, you are most welcome to ask. Let me go to the gallery and I think I can see some people here. Yes, students, you can just switch on your video or you can raise your hand. I will be able to see the hand and see this. Yeah.
I think there is no question, but students, can you please switch on your video cameras for a second? We can click a picture also for our records. Kindly turn on your video cameras.
Oh, what a wonderful.
Thank you. Okay, thank you.
Namaste.
Yeah. Right.
They are doing it very slowly.
Yeah.
Yeah. You are so good at moving working on mobiles. You should work very fast.
Sir, probably they may not be ready for the video. They must be leisurely. Like sometimes, presentable situation.
Yeah, that
When
can be the
you're,
reason because
yeah,
it's a
yeah.
holiday. Yeah, it's a holiday
Especially
also.
holiday and in online, they are, would like to take that
If
liberty.
you are not ready with the question, you can give your comments also.
Yeah.
Your comments are also welcome.
Any comments?
You can write in the chat box or you can write, speak out, raise your hand and speak out. Anybody else?
I think it could be, for them, it will take some time because it was a lot of information you have given.
Yes.
They will
Have to
definitely think about
realize-
it and the opportunities ahead are exposed. So thank you very much. Even a lot of things I also learned first time. I heard first time. So thanks
Yeah.
for this.
Consolidated
Very
presentation. Yeah. It
yes,
was a
yes,
very good.
yes.
learning experience for me also when I was preparing it.
Yeah,
I was
generally when you are giving, I think it's you dig out lot of things and do lot of referencing also. But
because then it becomes an inspirational story for us also to follow in IAPT, ma'am.
yes.
Why mission modes are important for IAPT.
Yes.
Sarthak, do you have any question? Are you from NIT? Sarthak, I can see you.
Yes, sir.
Any question?
No, sir, I don't have.
So did you find something useful in the talk?
Yes, sir. About the rockets, different types of.
You are doing what? Engineering
Uh,
physics or
no, sir, I'm in MSc second year.
okay, okay. So think of becoming ISRO chairman, because physics people have
Yes,
been
sir.
ISRO chairpersons,
Yes, certainly, sir.
which is worth trying, At least it is worth dreaming, isn't it?
Yes, sir. Fascinating. Space science is always fascinating, sir.
Sir, I can see one question from Kajal. She says, if we want to have idea to create a new thing, what we have to do?
Follow this golden circle approach. Why you want to do it, how you want to do it, what you will get out of it. That is the mantra of ISRO itself. So if it is why, start from inner part of the circle, come to how, and then what? What are you going to get out of it? So why ISRO program is there? To develop India, to reach out to 1.4 plus billion people of this country. So why is very clear. So you in that why itself start talking about various, missions, mission for communication, mission for managing resources. So there are so many missions, which emerge out of it. Mission for helping people learn. I think when we are talking of these, edX and Coursera kind of internet universities, they cannot function without these kinds of facilities in place. So we have a mission for education. And one of the first missions of education which was done was through that project of ISRO in collaboration with USA. USA said, we will give you a satellite, but you will have to create your own, infrastructure. The agency which we call as Space Application Center in Ahmedabad was a result of that. They wanted to create that infrastructure. So the design of antennas to receive signals, linking them with a television, this was all in-house. Let me tell you, you have heard about VSAT. VSAT is a technology which emerged from that program itself. Very few people know this. Professor Yashpal was very much part of it, who was once again a physicist.
Yeah.
Yeah.
Okay.
So I think we can wind up now.
Yeah. So over to Dr. Kuldeep. Sir, unmute yourself, please. Sir, you are muted.
Okay.
Yeah.
Thank you, sir, for your very enlightening talk today, covering whole journey of Indian space program, right from scratch to Chandrayaan and Aditya missions, and about highlighting about the ISRO achievements of launching 125 satellites, and this is a step toward the self-reliant of reliance of India. Uh, and also highlighting about the various applications, extensive applications of space technology in forest, agriculture, environment, ocean, water resources, soil mapping, and many other navigation, etc. So India has a pride of efficient and low cost solar and lunar missions. We can say it with proud today, and planning more new missions. So that's a great opportunity for all of us, all of us, and our students also to look into this field and search about the opportunities of their career uh, in this sector. And I would once again thank you, sir, for your this talk and sparing your valuable time. Uh, I am thankful for Gorpade Madam also for arranging all this talk. Now I will hand over the stage to Dr. Sapna for formal vote of thanks.
Yeah.
Thank you, sir.
So then thank you, sir. Thank you very much. Now, so once again, I'm thankful to Dr. Ahluwalia for, sir, your talk was very, very, very interesting and very informative. As normally it is actually, always your talks are, it's a pleasure to hear you, always. So your presentations not only highlighted our progress of India in space achievements, but also inspired us with the vision of self-reliant India. So we are grateful to you. I am also thankful to Ma'am Rekha Gorpade for all the arrangements of this talk. Thankful to Professor Kuldeep Kumar Sharma also for chairing the session, and all the students and participants over there who have joined us for today's session. I'm really thankful to them also. So thank you very much, everybody. with this, we come to the end of this session, and we hope to have such more talks in future also. So
Ma'am,
thank
there
you
is
very
just
much.
one announcement.
Yes, sir.
And I want to congratulate RC23 that
Thank you,
you
sir.
took this initiative to organize this talk.
Yeah.
I think more
Thank you,
such
sir.
things will happen in RC23 in future also.
Thank you, sir. Sir, there is one announcement for the students. There will be, all students must note that there will be quiz after this, so they can take 15 minutes, and I will share the link on WhatsApp group, and all the students of BTech and MSc Physics students, they will join for a quiz on this Space Day celebrations. So thank you, sir. Thank you all.
Thank you.
Okay, thank you, sir. Thank you, everybody.
Thank you. Thank you.
Have a nice day ahead. Thank you.
Thank you.